Hello and welcome to this look at how to process a tricky Q equals MC delta T question. I've actually done a walkthrough of this same question in another video, but in this one I just want to focus on some of the traps and pitfalls to look out for. So first of all, let's think about what the question's actually saying. So it tells you it's a question about energy changes, and they want you to work out the enthalpy change of this reaction, or delta RH, because you can see at the bottom that you need to calculate delta RH. So delta RH is the enthalpy change in terms of the mole ratio as found in the balanced equation. And secondly, you're given the equation there, and you can see that the substance for which you can work out the moles is HNO3. In the equation there's 2 moles of this, so it's worth bearing this in mind a bit later on. So the temperature readings, there are 2 readings, and they together make the measurement for temperature, or the delta T part of Q equals MC delta T. So as you can see, the maximum temperature is higher than the initial temperature. This represents an increase, obviously. So your final answer, delta RH, will be negative. That will reflect the fact that it's an exothermic change. Now this negative number won't come out of your calculator as negative, so you remember to account for this a bit later on. So let's now have a look at how we do the calculation. So like we said earlier, it was Q equals MC delta T, and you also have the means to work out the moles of AgNO3. That's coming up a bit later on. So the M is the mass of water heated. That's the 25 centimeters cubed. So it says assume that the density and specific heat capacity of the solution are the same as for water, and that all the aqueous silver nitrate has reacted. Now water, you should know, is 1 gram per centimeter cubed. That's something you need to be aware of. So that means that if it's 25 centimeters cubed, the mass of water heated is 25 grams. The 4.18 is the specific heat capacity from the data book or data sheet. The value is in joules, so that means the Q value will drop out of your calculator in joules, so that needs to be accounted for as well a little bit later on. So delta T is the difference between the 2 temperatures in Kelvin. Because it's the difference between 2 values, not a single value, there is no need to convert to Kelvin by adding 273 to the degrees Celsius. So that difference is obviously 28. You can see my calculator worked it out as 28 there. So that gives us 2,926 joules. Notice this is a positive number because there's no negatives in this equation here. But because it's a temperature rise, that must mean the heat transfer is out of the chemical system. So later on you're going to have to put this in as a negative value. There's the calculator proof that it's 2,926. Now, we also want the number of moles of silver nitrate. That's going to be volume times concentration because of the nature of the data we're given. We're given a volume and a concentration. So the volume is divided by 1,000 to turn it into decimeters cubed, and then that's multiplied by 0.512. That gives us 0.0128 moles. So let's collect the data that we have. The final part is to work out delta RH. Now notice I put in a negative value here because heat was released because the temperature went up, so it's therefore exothermic. So the delta H value for any exothermic change is going to be negative. So that gives us minus 228.59375 kilojoules per mole. But the mole ratio in the balanced equation has 2 moles of silver nitrate to 1 mole of magnesium. So we need to multiply this up by 2. The final part is to give your answer to an appropriate number of significant figures. So looking at the information, both pieces of data, your 25 and your 0.512, or sorry, 25.0 and 0.512, happen to be 3 sig figs. So you need to change this into minus 457 kilojoules per mole, because this is the least sensitive number of significant figures. If they were different, you would go for the lower number of sig figs out of the two. So there's our answer, and you can see the final marking point is for recognizing that it's 2 moles of silver nitrate in the equation that this is working for. Okay, hopefully this has been a useful look at some of the finer detail in this type of question. Until next time, thanks for listening and see you soon.